Hello folks, this is your practice problems video on area basics as well as the area of composite figures. So I've just got a couple of area problems here, so we're going to go ahead and jump right into it. Okay, so because especially with these area problems, you all, I'm hoping at least, have seen a lot of these formulas before, what you're going to see more often is like in problems, you're going to have to use these formulas in a slightly different way rather than me just like, for example, giving you the base and a height in a rectangle and asking you to find the area, right? You may have to, like, I may start with the perimeter of the rectangle and then ask you to work backwards to find the area. Or you may have to use your knowledge of right triangles in order to find missing values, right? Things like that, okay? Because this topic, right, you should have learned the basics of this topic in middle school, right? So the problems do get a little bit more challenging, right, when you get into a higher level math class, right? So I've just got a couple of problems for you here. I think there's only 4 of them, so let's go ahead and jump in here, okay? So in this first question, it says find the area of an equilateral triangle, okay? So that's important, that they tell me my perimeter is 30 inches, okay? So I give you a hint to use either the Pythagorean theorem or special right triangles, and you're gonna see why in just a second here, okay? So now, pro tip, right, especially for geometry, if they don't give you a picture, go ahead and draw yourself one. So this is my equilateral triangle. They told me that my perimeter is 30 inches. Okay, and remember, one of the defining characteristics of an equilateral triangle is that all sides are equal in length. So if the perimeter is 30, then that means my side length is 30 over 3. Which is 10. Okay, so each of these side lengths is 10. 10, 10, and 10. So that's partially helpful, right? Because it gives me the base, right? But if I want to find the area of this triangle, I also need the height, okay? So now there's a couple of ways you can find the height, okay? As a reminder, in an equilateral triangle, all of the angles are 60 degrees. So you could use, so this is 30 and 30 because this height divides this in half, right? So you could use your knowledge of special right triangles in order to figure out what this height is. You could also use your Pythagorean theorem to find what this height is. I'm going to use the Pythagorean theorem because I think that's the one that you all are like most used to. And it's often what is chosen. Like that's usually what you all tend to choose, right, as a problem-solving strategy, right? So I'm going to do that with one of these right triangles that I have in my drawing here. Now, I don't have this distance, right, from here to here, like it's not noted. I don't know what that side is because I'm looking for the height, right? I need to find the height. But if you remember, because you're dealing with an equilateral triangle here, which is like a more special isosceles triangle, that this height, that like my imaginary height that I drew in here, is going to divide this base in half. So this distance here is 5. So if I want to find the height, okay, I can do 5 squared plus my height squared equals my hypotenuse squared, which is 10, right? So this is 25 plus height squared equals 100. I'm going to subtract 25 from both sides. So I have h squared equals 75, and then I'm going to take the square root. Now you could do this as a decimal, but I'm going to reduce this and put it in simplest form, which is 5 root 3. Okay, but you can just plug the square root of 75 into your calculator if you want to, and you'll get the exact same answer. So if I do that and I do the square root of 75, that number is 8.66. Okay, so now I can find my area, right? Because I have the height and I have the base. So the area of my triangle is 1/2 of the base, which is 10, times the height, which I'll use the decimal here, 8.66. So if I multiply all that through, right, what you get is that the area of this triangle is 43.3 if you round, and then I need to make sure I use inches, right, use my units, and then it's inches squared because you're finding an area, okay? All right, so let's take a look at number 2, okay, which says to find the area of this square, right? This square that is inscribed in a circle that has a radius of 16 millimeters. Now, hold on. I give you a couple of hints here that you could use the Pythagorean theorem to find the side length, which you could, right? Because this side and this side, they make a right triangle here, where this would be like your hypotenuse, and then this would be like A, and this would be B. But there's another thing you can use here. If you recall, you can find the area of a rhombus, which, remember, a square is a special type of rhombus, using its diagonals. So that's actually what I'm going to use, okay? Just because I know the length of both diagonals, right? The length of both of those diagonals is the diameter of this circle right here. So each of them is 32. So if you recall, right, the area of a rhombus you can find by doing 1/2 of the first diagonal times the second diagonal. Okay, and each of these diagonals are both equal to 32, right? 16 plus 16, okay? So my area here is 1/2 of 32 times 32, right? And then once you get to this point, this is just a plug into your calculator kind of deal. Because honestly, I don't really want to do 32 squared in my head, right? So that's half of 32 times 32 is 1,024. And then cut that in half, and you get 512. And then I want to make sure I use my units, right? So millimeters, but then I have to remember to put millimeters squared because I found an area. Okay. All right. So here, in these last two, this is asking you to find the perimeter and area of this figure right here. Okay. And then the fourth one is asking you to find the area of this trapezoid. So I actually want you all to try these on your own, but I will give you a couple of hints here. Okay, for area, you can either divide this into two shapes, like a rectangle and a triangle, or you can solve it as a trapezoid. Okay, and then for perimeter, I'm going to tell you that you are going to need your Pythagorean theorem. To find this distance right here. Okay, and then another thing I'm going to tell you is make sure you pay attention to the units, right? Each of these little dots, like each of these little notch marks on the X and Y axis, are 2 spaces, right? So this distance, for example, even though it's only 1, 2, 3, 4, 5 notches, is actually 10 units, right? Because it goes up to 10 here. Okay, and then for number 4, this one's a pretty simple one. I just want to remind you what the area of a trapezoid is. Okay, so it's 1/2 of base 1 plus base 2 times the height. All right, so go ahead and pause the video, give this one a try, these two a try on your own, and then check back with me to see how you did. All right, folks, so go ahead and check your answers against mine. So for number 3, that was actually the more tricky part of this problem, actually, because you had to use the Pythagorean theorem, or you technically could have used your knowledge of special right triangles in order to find out what that slanted distance was. So the rest of the values for perimeter, the rest of the sides were pretty easy, right? This side at the bottom is 14 total. Okay, this vertical side here is 10. This distance here is 4. And then we just had to figure out what C was, this slanted distance. So I did that using the Pythagorean theorem. So I looked at my right triangle right here. I said, okay, A is 10, B is 10, and then I'm looking for C. So I got 14.14 when I plugged that into my calculator. So when I added all of those sides up, I got 42.14 for the perimeter. Okay, and then for area, I told you there were two different ways you could do this. You could either do it with the area of a trapezoid formula, or you could do it by dividing this shape into its two composite shapes, a rectangle and a triangle. And then finding both of their areas. And then I obviously didn't do the last part, which I'm going to do live for you here in a second, and add them together. So I did it that way for this one, just because I do have a trapezoid example for you on the next one, right? So the area of the rectangle is just 10 times 4, which is 40. The area of the triangle is 1/2 of the base, which is 10, times the height, which is also 10. So half of 100, which is 50. So my total area is just the sum of those two, 40 plus 50, which is 90. Okay, so now this is, again, one of those cases where you have to be careful, because obviously it's not like 90 spaces, right, in here. But remember, each square here is not just like one, like it doesn't have an area of 1, right, because of the units on the x-axis, right? Okay, then for my last one here, I'm just looking at the area of a trapezoid formula, and I gave you all of the information that you needed, right? I gave you both bases, and I also gave you the height. Now, the reason I can tell that 4 is the height is because it's a vertical distance here, because you have these two right angles right here. So that tells me that I'm dealing with a vertical distance. Okay, so you wouldn't want to use your slanted distance, right? That's no bueno. That's not the height of the trapezoid. So the area of my trapezoid is 1/2 of the sum of the bases times the height. So 1/2 of 5 plus 8 times 4, which is my height. So 5 plus 8 is 13. And then I did that reduction, right? 4 divided by 2 is 2, multiplied by 13, and you get 26. Now for this one, I do need a unit in my answer because I gave you units in the problem. So because it's an area, my unit is meters squared. All right, y'all. So that is it for this video, and I will see you in the next one. Bye.